So just to demonstrate what's going on in the actual treatment delivery that we're modeling here. So in this window we have what we call a beam's eye view. So if you were like a little mouse that crawled up into the treatment head and looked down on the patient, you're acting as the beam. This is what you're going to see. So as we rotate around the patient, which is demonstrated here, these little leaflets are going to move back and forth to account for the different positions of the structures as we rotate around the patients. So as I go through here, you can see the leaves moving back and forth rapidly. So they're accounting for the different positioning of those structures, allowing us to limit the dose that those structures receive while also delivering the prescribed dose that the physician would like to deliver to the tumor. So in practicality, as a dosimetrist, you need to tell the computer how to arrive at that solution. So there's all kinds of algorithms that the computer is going to try to run to meet whatever you tell it to. So over here on the left hand side is a giant list of this, in this case, brain structures that we want to try to avoid, and then up here is our what we call our PTV. So that stands for planning target volume. So that's what we want to deliver dose to. So I'm telling it I want this amount of dose, no more than that amount of dose, to get delivered to the target volume. And then what I'm doing here with the rest of these structures is saying, do not give X amount of dose to these structures and limit as much as possible. And so that's what's represented on this graph. This graph is, the lines are actually what's being delivered and how it's going to result for the patient. And these little wedges here are what I'm telling, the constraints that I'm giving the computer to try and help it arrive at the solution